Okay, this video is for Unit 7 Worksheet 4, and I'm going to go old school with my whiteboard and attempt to do a little review. First of all, our formula W is equal to mg. That is weight is equal to mass times the gravitational constant, and the gravitational constant is 9.8 meters per second on Earth. The moon, different. The other formula is F is equal to ma. That is force is equal to mass times acceleration. Now, weight is a force. Sorry, I can't point. Weight is a force, mass is mass, and the gravitational constant is an acceleration. So we need to remember labels. Force is in newtons and weight is in newtons. Weight is a force, so they'll always be in newtons. Mass is in kilograms, always in kilograms. Acceleration will be labeled in meters per second. That's the funky one. And our gravitational constant on Earth is 9.8 meters per second. Okay, let's do number one together. Alfonso pushes a box on a well-waxed, frictionless, that's going to be kind of a key there that we're not going to be adding friction, floor to the right with a 20 Newton force. There's our force, causing it to accelerate at, there's our acceleration. So let's highlight that, that's important. What is the mass of the box? So we are looking for the mass of the box. Okay, so from the question, we are looking for mass. And for some of you, depending upon what your where you are in math and what you can remember, to get m by itself is kind of straightforward. But if we take and divide each side by a, we have m left by itself, and m is equal to f over a. Or we can do a triangle, and triangles are kind of elementary-ish, but we can say force is equal to mass times acceleration, not g, my bad. And how this works is if you want to find force, you cover up force, F is equal to ma. If you want to find acceleration, you cover up a, and that's force divided by mass. And if you want to find mass, you cover up mass, and that is force divided by acceleration. I recommend you write this down somewhere. You can use it on quizzes, you can use it on tests. I won't hide the formula from you, and you're at home, I can't really hide it from you. So our formula we're going to be using for this problem is mass is equal to force, sorry, my bad, over acceleration. So mass is equal to force over acceleration. Okay, with our formula, mass is equal to force divided by acceleration. Our force was 20 newtons. Our acceleration was 1.5 meters per second. And when we divide that out, we get 13.3 repeating. Not going to get too excited about that because that's all calculator. And that's going to be labeled in kilograms. Mass is labeled in kilograms. And it asks you to do a system schema, a force diagram, and a force addition. But for this, since we're not in class, I just want to do the force diagram. So going up, we have a normal force, or force normal, on the box by the floor. Going down, we have the force of gravity on the box, comma, by the earth. And we have a force to the right. That's the force applied on the box by the person. And I did P. You could have done Alfonso or something like that. So the force is going to the right. And in this case here, since they are unbalanced, as long as Alfonso can keep up that 20 Newton force, it's going to continue to accelerate at 1.5 meters per second, as long as Alfonso can keep up that force. So if you have questions, don't be afraid to hop in on the Zoom. We'll talk to you later.